So, Jenny, I understand you've got a very interesting context here where you've got a mine that essentially needs to operate in the Arctic Circle. Um, it's not accessible by any other means other than sea. And one of the big challenges is how this base metal mine will serve its relevant markets through the shipping routes. Is that right?
That's correct, yeah. The other issue, as you said, since it is only accessible by sea, is they need to get all the supplies required by the operation in as well.
Okay, so interesting. So everything has to go out by sea, and all supplies need to come in by sea. And I mean, how does that work given the icy conditions of the, if we're talking about the Arctic, can you operate all year round? What are the issues there?
So the issues are that generally they can only operate within the summer months as the ice has melted a bit then. However, with that comes the issue that there is caribou migration, which limits the months in which they can operate. There are, however, vessels available that you are able to ship year round, but they need to be ice breaking vessels. And the capex cost of that and the running of them is a lot more expensive than the ships that operate just in the summer months.
Okay, so it's quite interesting. It sounds like you've got a lot of interesting trade-offs here. You can operate during the summer months, which is essentially 2-3 months, on the more cost-effective vessels, or you can say I'll operate all year round on the more costly vessels. But not only that, you've also got issues with caribou migration affecting the shipping paths, etc. So it sounds like there's a lot of trade-offs. What other trade-offs do we consider in this kind of situation? Go.
Okay, well, one of the main ones is that there's two routes in which the vessels can exit the operation, the western route and the eastern route. There also have multiple destination ports at which they can offload their concentrates and reload with supplies. Some of these are only accessible via the eastern route and others only by the western route. The other big option is the concept of transshipping, where they unload at a given port and then transship to a final destination port.
Okay, so you can make better use of your summer months by shipping to closer ports, but then you have to reload the stuff onto the product onto other ships. So there'd be an additional cost there.
Yeah, there'd be an additional charter vessel cost for the concentrate to the final destination ports. In addition to that, as we see here, there's three other considerations we can take into account. The vessel fleet size, so that's the actual size and capacity of the vessel, and then the composition, so how many of each vessel you'll have within your fleet. And one of the other major ones is labor type, and depending on where you source your labor from, it could be potentially much more expensive overall.
Okay, so Jenny, what kind of model would you build that would allow you to run scenarios assessing these different types of trade-offs?
So if we look at our model design, over here in the middle we have the core model that was developed, which obviously is based off some key inputs that need to be inputted into the model. This includes things such as the vessel capacity, distances per route, different ports, etc. However, then per scenario, some key selections need to be made, such as the actual vessel type to be used, the start dates of different voyages, the destination port to be visited.
Okay.
The model then produces some operational outputs, some shipping outputs such as travel days, some key KPIs such as the cost, the OPEX and CAPEX costs. It also flags if you're breaking any constraints, such as shipping within the Arctic region during the caribou migration time.
Okay, great. So can you show us what kind of scenarios you evaluated there for using this model?
There was a base case scenario in which they believed would meet the requirements. However, we did test alternate markets, bigger fleets, a scenario in which we optimized the labor, a scenario in which we transshipped, and lastly a scenario in which the western route was used.
Great. And for each of these scenarios, you made various selections using the model by tweaking and changing fleet sizes, ports, etc., which I assume you can show us in the model now. Can we start off with the base case, and can you give us an insight as to whether the base case was a good scenario?
Sure. So if we were to go into the model now, we will be using the selection dashboard and scenario scheduling screens to set up the base case. In the selection dashboard screen, we can select the vessel types making up the fleet, the specifications, the routes traveled, some voyage inputs, the destination ports, and whether transshipping will be done. On the scenario scheduling screen, we now need to start making more voyage-specific choices. Choices such as how we're going to allocate the vessel capacity in terms of commodities shipped out. We also need to select which supplies are going to be shipped back per voyage. We can also set some layover days at the ports if we need to avoid migration, etc. What we see over here is that we have a summary of each voyage, the start and completion dates, and these can be controlled using setting up the start date with the completion date being calculated based on previous selections.
Okay, great. So now that you've configured the parameters for the base case, how do we know we're not breaching any constraints such as our originating port running out of stockpile capacity or the caribou migration not being influenced?
If we were to look on our constraints screen, what we've got set up is all the constraints within the model, and we can see over here that none of the supply or concentrate stockpile capacities constraints are being broken. However, over here we can see that 3 of our voyages are breaking the migration constraint, and this will need to be looked at before the scenario is viable.
Okay, so we have 3 voyages that are happening during the migration period. Clearly, that therefore is not a valid scenario. We can't continue to look at the financial results. How do we remedy that?
So to do this, we need to go back to the scheduling screen, in which I will resolve the migration constraints by doing the following. For the first vessel, we will keep the vessel in the destination port for 30 days.
Go.
Having done that, we can now see the new dates, completion date for Voyage 3, and we readjusted the start dates of Voyage 4. For vessels 2 and 3, we will keep them in the client port until the next shipping year.
Okay, great. So can we move to the constraint screen now and see whether that has actually cleared the constraints for the caribou migration?
Yeah, if we look on the constraints screen, we now see that the caribou migration is no longer a problem, and this is now a potentially viable scenario.
Okay, and the remaining constraints are soft constraints, so we're not concerned about those. So can we move on now to look at the operational and financial outcomes of this particular scenario?
Yeah, sure. So if we go to the KPI dashboard, we have some high-level outputs from the model, such as revenues, costs, and quantities. However, what we can see is that for the selections made, this is not a viable scenario, as we're not able to meet our targets in terms of zinc concentrate shipped or supplies required within the year.
Okay, so that essentially, as I understand it, would mean the mine's not viable without the supplies and without the zinc target being reached. So operationally, we have to revisit the scenario and somehow either introduce more voyages or make our ships bigger. Is that right?
That's correct. So we're going to see if we can remedy this by making one of our vessels operate all year round and changing it for a PC2. So over here, I'm going to change the vessel type for vessel 2 from a PC6 to a PC2 so that it can operate all year round. We can now go and see what the operational and financial impact of this is. We can now see on the KPI dashboard that we now meet our operational targets, and this now makes the mine viable.
Okay, great. So I can see our zinc is at 100% and our other requirements are at 100%. And this is great for a high-level overview of the scenario, but is there a way we can see more detail around the scenario in terms of what gets shipped when, what our stockpiles look like, and so on?
Absolutely. For this, we will be looking at the production and cost analysis screens. So on the production analysis screen, we get a breakdown of what was shipped per voyage in terms of both concentrate and supplies in voyage order. We also have the stockpile balances for all these stockpiles. Finally, we can also see the number of days each ship was operating within the year. With vessels 1 and 2, we can see they were operating majority of the year, while vessel 3 was really only operating within the summer months.
Okay, so that's a nice production overview. Can we jump into the costs and see those now?
The cost analysis screen gives us a couple of waterfall charts in which we can see the revenue per commodity, their capex, total capex costs for each vessel and the storage, and then the OPEX costs by each cost type. We also can look at the unit costs, so we can see the total unit cost for each voyage, broken down into the different activities. Then the OPEX unit cost, total OPEX unit cost broken down per cost type, and finally the total OPEX cost per vessel.
Okay, so the value in this tool is the ability to run multiple scenarios and be able to compare between those to find what is ultimately best for the business. Can you show us how you can compare multiple scenarios here?
Yeah, sure. If we're to go to the scenario comparison screen. So on the scenario comparison screen, we have selected our base case scenario. We have also included 5 comparison scenarios in the model, which we would like to compare the results from. This could be expanded to include any number of scenarios. If I were to now compare scenarios 1, 2, 3, and 5, we can quickly examine the results, and what we can see, for example, is that in scenario 2, the zinc production target is not met. Scenario 3 uses an alternate vessel. The revenues for the scenarios may be quite similar, but again, where an extra vessel is used, the capital expenditure is more. The transshipping, for example, has an effect on our OPEX costs, and thus we can compare the results.
Okay, so what if we wanted to ask a specific question, such as comparing two scenarios, one might have a higher operating cost, and we want to understand exactly what the contributors are to that higher operating cost. How could we do that?
We could use something called the attribution analysis. So in this example of the attribution analysis, we're comparing 2 scenarios, the transshipping option with the optimized labor. And what we can see is that the one has a $5 million more total OPEX cost. The reason for this is that in the transshipping scenario, we can see that it has much less fuel costs, but this is superseded by the much bigger increase in the total crew costs for the transshipping scenario.
Okay, so can you perform this analysis comparing any 2 scenarios that you create?
Yeah, so you can select which scenarios you would like to compare. You can also select which output you're comparing this on, so you could compare tons shipped or revenues for different scenarios as well.
Okay, Jenny, well, thank you very much for that demo. I understand you used the Qerent platform to build this model, and that the platform has been used and is applicable in other areas as well. Can you tell us a bit more about that?
So we've used this platform to build models for operational models for performance management and continuous improvement in both open pit and underground mines, strategic portfolio management, as well as operational and enterprise risk quantification models.
Okay, great. Thank you very much.